Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's SecurityBoulevard.com webinar, brought to you by Techstrong and Snowflake. My name is Cody J. Brown. I'm the host of Techstrong Learning, and we have an exciting panel ahead. First, I have just a couple of housekeeping notes to cover. First, today's session is being recorded, so if you miss any of our discussion, or you'd like to rewatch or maybe share with a friend, the on-demand recording will be made available shortly after we conclude our live session today. If you have any questions, we want you to send those in to us using the Q&A tab, which can be found on the right side of your screen. That's also where you're going to find the chat tab, and that's where we want you to get to know your fellow audience members. Maybe let us know any thoughts you have throughout today's program or where you are joining us from. And of course, before we close out, we are giving away 4 $25 Amazon gift cards, so be sure to stick around. The topic of today's program is implementing identity access prioritization and risk-based alerting for high-fidelity alerts. And I'm joined by Haider Dost, Manager of Threat Intelligence and Detection at Snowflake, and Daniel Wildchuck Stern, Senior Security Engineer at Snowflake. We are also joined by Kelly Huang, who will help us out with some question moderation. So, Haider, Daniel, thank you both so much for joining us today. Haider, you want to take it from here?
Hey everyone, welcome to our presentation on unlocking the magic to high fidelity alerts. So my name is Haider Dost. I lead threat intelligence and detection engineering here at Snowflake. Prior to that, I led threat detection at Freddie Mac. And prior to that, I was the CSOC manager at Capital One.
And I'm Daniel. I'm a security engineer under Haider. Before this, I was doing some offensive security stuff at Praetorian and US Air Force. And you can find me enjoying computers, coffee, and my cats.
Cool. So today we'll be discussing how to shift from detection 1.0 to 2.0, which will cover the benefits of a security data lake, the importance of establishing a detection development lifecycle with detection as code, and how we've implemented asset and identity prioritization and risk-based alerting at Snowflake. Cool. So to start, detection 1.0 is a grouping of some of the most critical challenges that we've seen threat detection teams struggle with. We observed that most detections are being built with no formal development process, which leads to a lack of alert quality and detection tech debt. Alerts are not being prioritized outside of the assigned severity rating. So you have analysts struggling with, with multiple alerts with, the highest or critical severity and the challenge of which one they should work first. Furthermore, alert fatigue and lack of alert correlation continue to plague security teams. I cannot count the amount of times, I was working in a SOC and you have alerts that are triggered by the same user and or host over the course of multiple days. And they're not being correlated by the analysts that are working on the shift. And you can't blame the analysts when they're already dealing with alert fatigue. The responsibility falls on threat detection teams to provide this correlation for SOC and IR teams. And by doing this, this will ensure that the alerts are related alerts are grouped, and that the analyst won't have to manually conduct a search within the ticketing system. Lastly, I want to highlight that the traditional SIEM model has failed security teams. With the adoption of the cloud, security teams have seen a drastic increase in log volume, right? Flow and EDR log volumes alone can destroy your SIEM license. And beyond that, with traditional SIEMs, they're not ingesting business data such as ServiceNow, Salesforce data, or even Workday data. Next slide, please. So detection 2.0. Detection 2.0 is a grouping of some of the solutions that we've implemented. So we feel that it's important to establish a formal detection development process with detection as code to ensure that your alert quality is enhanced. And also this will provide documentation for the alerts that your team is writing. And so when you have a SOC or IR team, they will have documentation associated with the alert and they won't feel blindsided. Furthermore, implementing asset and identity prioritization will help the SOC and IR teams because alerts will be dynamically adjusted based off the criticality of the user or asset tied to the alert. Furthermore, with risk-based alerting, you can really help combat alert fatigue by reducing the overall volume that's going to your SOC and IR teams. And furthermore, when you're correlating alerts together, they're going to have better context when they're working alerts, and it'll all be, in a single sort of pane. Lastly, with adopting a unified cloud data platform, threat detection teams can build advanced correlations that look at security logs and business logs together, right? And so SOC and IR teams won't also have to, pivot across multiple platforms to work on the investigations.
So now let's touch on some of the benefits that you get from working with a security data lake. So as Hyder mentioned, the traditional SIEM model sort of separates your enterprise data from your security and information and event management system. A traditional SIEM has just your security data. So what you would think of as like your EDR logs, your CloudTrail logs, your logs that people I would say like specific to security. And then your enterprise data, your Salesforce, Workday, HR stuff that people don't traditionally think of as security data lives in your, other systems, maybe a variety of other systems. However, what we've seen is that often in the course of investigations, you want to work to pull this data into your SIEM platform in order to do some correlation. Maybe you want to figure out if somebody, was onboarded recently or recently was offboarded. Maybe you want to understand what group somebody was in or what their manager was. Well, if this data lives in other systems, it becomes harder to do that kind of analysis in an automated way. It slows down investigations and creates friction. So with a modern security data lake, you see now that you're not just pulling in, your security data, but you're pulling in data from all of your resources in order to do this kind of correlation automatically and really sort of present all the information to the analysts so they can make quick determinations on an alert and take quick action and appropriate action as necessary. And this can be further enhanced by working with some of our partners like Panther and Hunters, who can also work on top of this data.
So now we'll dive into Snowflake's implementation of the detection development lifecycle. So this is Snowflake's implementation of this lifecycle. It's broken down into 6 phases. The blue circles make up the detection creation phase, and the orange circles make up the detection maintenance phase. Let's dive deeper into each phase. In my opinion, the requirements gathering phase is the most important phase of the lifecycle. Detection teams can establish an intake system at this phase to allow for the submission of detection requests, right? And it's through these submissions that you can collect all critical details and requirements that you need in order to properly streamline this process. So it's important for detection teams to partner with stakeholders and understand what is being built, ingesting threat models, conducting risk detection mappings, and providing logging requirements. And it's really important to sort of partner with stakeholders and sort of socialize that you have this process, because it's the absolute worst, when you get a request to build detections for an application or system after it was built, right? And you're serving as a blocker for the system, going live, or you want to start building detections and you don't have the logs, right? Or there are no threat models. And it's also important that during this phase, teams, our detection team builds a risk and intel-based prioritization process so that, detections are being built in a risk-based approach.
So after you have your requirements, the next step would be design. Just like any solid development team doesn't just begin writing code, you should apply similar principles to your detections as well. At Snowflake, we use the alerting and detection strategy framework as sort of a solid design doc that we use with our detections. So we fill out this form and this documentation prior to writing any code that goes into our detections. Another key part of this document is that we partner with our incident response team during the development. A key section of the ADS is the response section, and we ensure that the IR team has an opportunity to fill that out or add on to it as they see necessary, as well as review other sections. Because this ADS is presented to the IR team when an alert fires, it's critical that they've seen it before so they know and are able to handle an alert if it comes into their queue. Now, after you've done design, the next step is development. This is the phase where we turn our detections ideas into code. A key part of this is also having some of your stuff templated out. That helps for a number of reasons. Speed is a key one, right? You don't want people reinventing the wheel every time. If there's common patterns or parts of your code that you want to reuse, see if you can template those out to also help with onboarding as well, right? So people may be unfamiliar with your systems, but by having clear and documented templates, it can help new folks get up to speed quickly. Another part of this that it can assist with is metadata tagging. Metadata is stated about your detections, right? So maybe MITRE ATT&CK tags, what system or platform the detection is applicable to, data sources, etc. Having these tags as part of your detection as code and having them templated out can help enforce standards so that things are tagged consistently and appropriately. So we have a pretty simple basic detection. We're looking for exfiltration or sort of communication outbound on ports 22 or 3389. So we run this code, we look at our event, and we say if the destination port is not in one of these ports, then we'll return false. And we can also do a couple other things like filtering out on certain networks or certain IP address ranges. So what are some of the benefits that you get with detection as code? Testing is a big one, and I'm going to talk about testing a lot. As Heider mentioned, one of the things that really plagued SOCs is detections firing a lot of false positives, even maybe true positives, but in large volumes. So by working through testing in automated and structured ways, you can really work to reduce that volume and catch errors before they hit production. Backups is another big one as well. There's certainly been times, when maybe somebody new to the system maybe deletes a rule, or even somebody just makes an error and stuff gets deleted. By having all your detection as code, you can simply make another push and have everything go back to the way it was in your main branch. Role-based access control is another big benefit as well. By keeping your code in some sort of code repository system or your detections in the code repository system, you can get role-based access control as a benefit. You really should start be treating your SIEMs and your detection systems the same way that you treat any other production system. Just like you wouldn't want developers being able to SSH into your production servers, so should you also apply those principles to your SIEM. You want to be able to control who can make changes to the system and how those changes get made. A really strong system only has changes made to your SIEM after they've been approved and merged by your code repository system. Another benefit is cost and cost management. There's definitely been times when I've been working on rules in older SIEMs where I put something out, I was testing something, and I kind of just forgot about it. And it may even still be running today. But with detection as code, the rules that you have in your production SIEM are exactly the ones that you have in your code repository. So you can simply review that, conduct a quick analysis, and make sure there's no sort of tests or hidden things floating around, eating up cost or eating up performance. Resiliency ties into backups. Fixing accidental deletions and changes is very key, especially if something gets overwritten or something gets changed and you're like, what is going on? Where did this rule go? Who made this change? You can analyze how that change got made and push old versions in case something breaks. And then reusable logic as well. One of the things that we often want to be able to determine is, if an IP address is one that belongs to Snowflake. We use a lot of cloud infrastructure, so that can be a challenging thing to do. So we wrote up a function that allows us to determine if something is a IP that's owned by Snowflake at that time or not. Well, that's another useful thing to do. So we're able to make that function available to a bunch of other detections. And rather than having engineers reinvent the wheel every time, they can call this function and really reduce the amount of development time and enforce consistency as part of our detections. So the next phase after you've done development is testing and deployment. So there's a number of different things you're going to want to look for when testing. Accuracy and precision are one, right? You want to make sure that you're actually getting true positives and that you're actually looking for the behavior that you want to be looking for. So being able to generate behavior or sample data in your test systems to make sure that your detection is accurate and precise so that you have are looking at true positives and learning on just true positives is an important part of testing. Another thing you want to look for is alert volume. So maybe you're looking for true positives, but you're saying like, oh, I want to look for any time, the command prompt starts. Well, you may have an accurate and precise alert that looks for just that, but now it's alerting 10,000 times a day because you have a bunch of developers starting their command prompts every day. So making sure that the alert volume is something that's reasonable and can be handled by the incident response team is another key part of testing. Then validation, right? So you want to make sure that the rule that you're writing actually matches the design spec. This is where peer review can come in. They can look through the design spec in the ADS, look through the rule and say, hey, does this rule match this approved ADS? Are we actually going to be searching for the behavior that we think we're going to be searching for? And then you can deploy your rule to production using version control as well, so that once something gets deployed, you're able to keep track of, hey, what versions do we have live? How are we making these changes to the system? Is the version that we have in production the one that we would expect? So how do you manage these systems? Well, you can do that through continuous integration and continuous deployment automation. Essentially, what these tools allow you to do is to build your code and deploy it to where it needs to go in a controlled and automated way. So essentially what you can say is, anytime I make a change, I want to run a script. Sounds kind of vague, but that's kind of what these tools allow you to do. They allow you to be flexible with the kind of automation that you want to run. Do you want to run Bash scripts? Do you want to run Python? Do you want to run Ruby? You can trigger different scripts to run when different actions occur and really build out a lot of flexibility and automation in your deployment systems. So let's take a look at what one of those sample pipelines may look like. So let's say you make a change to code and you commit it to your code repository. Well, your continuous integration pipeline can kick in and say, oh, well, somebody made a new commit. Let's build it. Let's run some unit tests to make sure that everything's working. Maybe you want to look at integration tests as well, and everything should check out there. So an example of a useful unit test, maybe you want to say, oh, well, whenever a detection runs, it should always have these 5 fields as output. Well, a unit test can run some quick parsing and say, cool, we have all the fields that we would expect. Integration tests allow you to say, how would this integrate with downstream systems? Server platforms are becoming more and more common nowadays. So double checking that your alert looks right may not be enough. You may want to double check that it integrates right with downstream systems that would kick off various automation. This is where integration tests can come into play, and you can work with your incident response team to set up automation with your SOAR platform to double check that your alert output is going to match your SOAR input. Once all those checks take place, your continuous deployment pipeline can kick in. You can review the rule, set it up in a staged environment, and then deploy it to production once everything checks out. You're not done there, though. Monitoring is the next part of the development detection lifecycle, and another key part of ensuring that your IR team stays happy. As we mentioned before, cost is always a big driver for a lot of teams. So you want to monitor your detection performance. Where we've seen this really kick in is when we deploy a rule to an environment that maybe has one AWS account in scope, and everything looks good. But then we may change things up, or new accounts may get added, or new resources may get added. And now instead of looking at 10 events a day, that rule is now looking at 1 million events a day. And the detection performance has really started to churn. So you want to be able to monitor, hey, what rules are performing? What is the expected time to complete? How many resources or events are they looking at? And are those things changing in unexpected ways? You also want to look for where rules may fail. We can do all these tests, we can do all these reviews, and bugs may still occur. So you want to be on the lookout for bugs, especially in providing your incident response team with an opportunity to surface these bugs. What we've done is that there's a little field in our tickets that the incident response team can check and say, hey, this rule needs work, and here's why. That then kicks off automation, where that comes back to us, and we have to go look to fix it. You really want to make it simple and easy to get feedback from your downstream teams. Otherwise, they won't give feedback. They're going to get upset and frustrated, and then you'll just never know that all these things are breaking. So make it simple to give feedback, and then actually take that feedback into account, prioritize it, and work to address it. Another thing you maybe want to look out for is the opportunity to decommission rules. While I love creating rules, turning them off makes me happier, because that means we've mitigated the risk in some other way. We can just turn this off, save the performance, and move on to other things. So this can be done whenever new changes get made. Maybe we do yearly alert reviews, and then we can just double check and say, hey, do we really still need this rule? You also want to do continuous testing. So while you also want to test during development, a key part of monitoring is continuous testing to ensure that things are still working. You can do that with automated unit tests that maybe run every day, but it's also an opportunity to bring in other teams. Maybe your red team can conduct purple team exercises to double check that things are validated correctly. And you can really use these as opportunities to tune rules or even build new rules if you identified gaps that you weren't aware of previously.
Cool. So now let's discuss asset and identity prioritization and why that's important to implement. For anyone that's ever worked in a SOC with an alert queue, I'm sure you've had an alert backlog and you've been faced with the dilemma of which alert should be worked first. The obvious answer is to work the alert with the highest severity, be it your criticals or highs. But what do you do when you have multiple alerts of the highest severity? The answer here is that detection teams need to dynamically adjust alert severity based off of the criticality of the user or asset tied to the alert. And what do we mean by that? If you have two critical alerts in the queue that have been triggered, and one is triggered by a user that doesn't have admin privileges, and one is triggered by a user that does, let's just say like they're an Okta admin, clearly you should work the alert that is tied to that admin. And this needs to be automatically done for SOC or IR teams that are triaging the alerts.
So let's dive a little bit more into how we went about implementing this in Snowflake. There's sort of a 4-step process here, and we'll dive into that a little bit more in the next slides. But the first step is to just define your AIP calculation or sort of your range of scores. You want to uniformly classify your systems and users within the organization. Aggregate users and scores across these various systems, and then integrate your scores with your severity calculations. So let's dive into those steps a bit more. So the first thing we did was we built out an AIP matrix. So on the left, we have the priority of the environment, and on the top, we have a privilege. And we were able to go through our various systems and say, hey, what is the importance of this system or the environment in which it's operating? And what privilege does this user or system have in this environment? So if somebody is in an environment where there's restricted or critical information, and they're an administrator, we give that a score of 16. Or if somebody has no access to like a public system or a restricted system, that's a 0. And we're able to sort of do this mapping to say, like, for any given environment or system, what is the privilege that an asset or user has to that system? So let's go over some examples. From the top, we have our AWS prod systems, and on the bottom, we have our development systems. And we have 2 users, John and Jane. John has admin to both systems, and Jane only has modify. So in the top, we see that John, the environment has a risk score of 4 for both. However, because John has admin, his privilege risk score is critical and therefore a score of 4. We multiply these out and his final score is 16, while Jane's is 12. In the bottom, their privileges are the same again, critical and high. However, the environment is only internal or medium score, so the risk is 2, leading to a final score of 8 and 6 for John and Jane respectively. So what's going to happen from this? Well, if you go through all of these various systems, you're going to end up with a lot of different scores for a lot of different users. Well, you want to sort of turn that into one final score. And we used a harmonic mean function for that. So let's say we have a user who has admin to GitHub, normal access to Okta, and admin to an internal Snowflake instance. We can calculate the harmonic mean of those scores and store it in a single database. Therefore, for every user or entity, there is one corresponding AIP score. Then, when we run our Panther rules on top of our SQL, we can use Panther's Python functionality to reach into that database, look up the score for an entity or user, and if it matches, dynamically adjust the severity. So let's look at a pretty basic example. We have 2 users, a normal user and an administrator. Both of them have an alert fire for their laptop with a default score of severity of medium. When we look up the normal user in the AIP database, we get a 4x multiplier. When we run our further calculations, the final severity for the score stays the same. However, when we look at the administrator, we find that they have a 16x multiplier in the database, and therefore the severity increases to a high, and the queue can be dynamically adjusted to account for that change in severity.
Cool. So now let's talk about risk-based alerting. Alert fatigue continues to be a challenge for security teams. And on top of that, when an analyst is working on a shift and they're working with multiple alerts throughout their shift, more often than not, they're missing the context of knowing how many related alerts are tied to the one that they're currently working, right? And if analysts aren't manually doing the search, it can present a serious gap and malicious activity will be missed. This is where risk-based alerting can help alleviate these challenges. And to start, the number one question that detection teams need to start asking is if every detection needs to be atomic. And what do I mean by atomic? Atomic detections are ones where every time they fire, an alert surfaces. And the answer to that is no, right? Every detection doesn't need to be surfaced, or every detection doesn't need to surface an alert to the SOC. By implementing risk-based alerting, you can better control this. How? Well, with detection, with risk-based alerting, detections can be grouped, right? Your low fidelity detections, like along with your critical detections, can be grouped, amalgamating risk scores across entities and only triggering when a threshold is breached. And with this approach, detection teams can better control the overall volume of the atomic detections, and by reducing the overall alerting volume while not losing visibility to non-atomic detections. So your risk breach detections can be, low fidelity, high volume detections grouped with atomic ones, ultimately surfacing to the SOC or IR team based off of whether or not they breach the risk scores. So let's dive a bit deeper into this. To start, detection teams need to establish criteria for the type of alert that you're building. And this should be part of the design and development phase of the life cycle. And ultimately, detections will fall into two categories. You have risk builders and atomic detections. Risk builders are those that are not inherently malicious, right? Those that don't basically need to be atomic, and they don't need the immediate attention of your SOC or IR team. And more often than not, these alerts are ones that are better utilized in correlation with other detections and alerts. Atomic detections are those that are always alerting on badness and should require the immediate attention of your SOC and IR teams. Cool. So once you've defined, the alerts that will remain atomic versus those that can be converted into risk builders, you can start to build those threshold breach alerts, and you can establish thresholds for a day, for a week, for a month, whatever works for your organization. You can also start to get creative and build detections that group, multiple MITRE or tactics or techniques together. And as you can see in the picture here, this is an example of a 24-hour threshold breach detection that we've built in Panther. And what's really interesting here is that, and what I like to highlight is, if we didn't have this type of alerting set up, this would have resulted in 3 atomic detections. And I'd also like to highlight the correlation that's happening. You can see that, you have multiple alerts that are tied to, one particular actor. And if detection teams aren't doing this correlation and this context may have been missed when each alert is being worked individually. So risk-based alerting with hunters. One of our other partners has this capability built into their platform, and they have out-of-the-box detections that can be applied to your environment. But what's really special, and what I would like to highlight, is the stories capability. If you take a look at the picture in this presentation, over the course of 12 days, 5 detections triggered, all with various risk scores, and all of the activity is connected. And the relation is highlighted via a graph, right? Attackers think in graphs, defenders think in lists. Forget who said it, but famous quote. And you can imagine the difficulty a SOC analyst would have without this grouping being done automatically for them. And so the benefit here is if you have a platform like Hunters, or you build risk-based alerting, yourself, SOC and IR teams can better action alerts because they're going to have all of this context to work with when they're working their cases.
So now we're going to talk a little bit about how AIP and RBA can work together. So the way we think about risk-based alerting is it's kind of like a bucket filling up with risk. Each bucket corresponds to an entity, whether that be a user, a human of some kind, maybe a system, like maybe an IP address or a virtual machine. And for these non-atomic detections, when they fire, they sort of accumulate risk or put water into this bucket. So without AIP, each alert kind of fills up the bucket at the same rate. Whether it's user at snowflake.com or admin at snowflake.com, if two lows fire, they're both going to fill the bucket up at the same rate. However, with asset identity prioritization, prior to the alert going into the bucket or water being pulled in, we can dynamically adjust the severity of that alert and increase the risk that we've now added to that bucket. So now when we have two lows for user at snowflake.com, it's as it was before. However, with admin at snowflake.com, we dynamically adjust the alert that's being correlated with RBA and therefore add more risk to the system. And therefore, even though there's two lows, because they're associated with an admin, we have that trigger an alert with RBA.
Cool. So unlocking the magic to high fidelity alerts. By implementing a detection development lifecycle, detection teams will be empowered and have a well-defined process to produce and maintain their detections. And with detection as code, are adopting detection as code paradigm, you'll have structured detection development. With asset identity prioritization, alerts will be dynamically adjusted based off of the criticality of the user or asset tied to the alert. And with risk-based alerting, you'll be able to combat alert fatigue by grouping and correlating multiple alerts together.
So there's sort of two main takeaways that we want you to have with this as well. The first is that you want to have tested processes. So a detection development lifecycle, we're a fan of our own, but if you want to take it and modify it or come up with your own, having a clear process for how you go about building and maintaining your detections is key. The second one is that you shouldn't really be thinking about data as big data anymore. We're kind of past that point. There's data now. There's so much of it for every system and every team that saying big data is sort of doing a disservice to yourself. And really, you should be thinking about it as data. There's going to be a lot of it. Build and design your systems assuming that you're going to have terabytes and probably petabytes of data.
Thank you. We hope you enjoyed this presentation.
Awesome. Well, thanks, Hyder and Daniel, for this presentation. I do have a few questions for you guys. The first one is, you mentioned monitoring detection performance earlier. How do you actually do that today? Is there like a dashboard that you use to monitor? How do you build that dashboard if there is one?
Yeah, so we have multiple dashboards, or I should say panels within dashboards that we're using currently to monitor for the performance of our detections. I'd say, for one, there's that immediate performance feedback that you get, and that's via our detection improvement request, right? Our incident response team will let us know if an alert is blowing up, but over the course of, let's just say multiple days or months, right? We're tracking the performance based off of the closure statuses of our detections, and what we're doing is tracking that, but also tracking the volume of detection improvement requests that are also associated with detections. So we're looking at it from multiple different angles, all to ensure that detections are performing as they should be. And Daniel, I don't know if you want to add anything to that.
Yeah, there's a few specifics that we can look at. So we use a lot of scheduled queries. So if some of those start timing out, we have timeouts built into them to ensure that they don't turn into resource hogs. So if something starts timing out repeatedly, we'll take a look at that. We can also look at things like how much data it's scanning. So if it's something scanning, 10 megabytes every query, and it started to increase dramatically, we can start being like, okay, well, this is scanning more data, it's taking longer, and start trying to figure out what's going on there. So there's some specifics and some of the Snowflake data available to us that we can track as part of these dashboards.
Awesome. And do you get those dashboards via, Snowsight or via one of the partners that you mentioned earlier in this presentation?
Yeah, the dashboards are built in Snowsight. So we build those dashboards in Snowsight.
Awesome, thank you. And then there's one last question that you mentioned earlier in the presentation about pulling in enterprise and security data into one place, which is essentially, using Snowflake as your security data lake. Can you talk a little bit more about, how do you actually pull that data into Snowflake? How hard or easy is it? And then do you use that same data set for other security use cases other than threat detection?
Yeah, I'll kick this off and then I'll hand over to Daniel. This is something that I think hits home for me quite a bit, given previous organizations that I've worked with where we didn't have security data lakes. And what I'd like to start with is just the overall benefit and ease by working, in Snowflake, our own product, and having all of our logs there. There are no logging gaps for us in the detection space, I'd say, like that I'm actively aware of, I should say. I can't say that, we have no logging gaps whatsoever, but yeah, there are no immediate logging gaps that I can think of. And we're not ever challenged with, having to select critical log sources or having to eliminate any sort of log sources. And so whenever we want to, we can build detections, with all of the log data that's available for us. And it really enables the team to build complex correlations. You can start to build detections and correlate against Workday data. And more often than not, our ServiceNow, for example, SOC analysts, some of the initial steps for detections will be like the first step of a playbook will be to pivot to one of those platforms. And so now the detection team is empowered to sort of automate that within the detection. So yeah, I'll hand off to Daniel if he wants to add anything to that.
Yeah, to add on to a little bit to what Heider was saying, and then some, right? I mentioned friction earlier, right? Anytime that an analyst or incident response team has to go to another system or run another query, that's friction that slows them down. So what we're trying to do with threat detection is sort of foresee and then also ask IR, hey, what are the pieces of information you're going to want to see when you get this alert? Let's pull that into the alert automatically so that the very next step should require a human. If the next step requires, a machine getting some information, then I say that we failed at our job. So we really want to make the next step human actionable. As to how we get this data into Snowflake, there's a couple of different ways. So Snowflake offers, services like Snowpipe to get the data in. There's a couple of partners as well who can sort of do some analysis and parsing on some of the more complex data sources. But the way we set it up is that the team that owns the system is responsible for data ingest. And we're able to sort of work with these teams to say, like, hey, we need this data. If they already have it, then they can simply grant it to us via the roles that we have, or we'll work with them in order to get it ingested into Snowflake.
Got it. Well, thank you both for such an amazing presentation. And thank you all for joining our webinar today.
Well, Kelly, thank you so much for handling the Q&A for me. And thank you to Heider and Daniel for taking the time to join our discussion today. Any questions that we were not able to get to, we'll make sure to get those over to the folks at Snowflake. So I'd like to quickly remind our audience that today's session was recorded. You will receive an email with a link to access the recording on demand, or you can find the recording living on the Security Boulevard website at securityboulevard.com/webinars. Just be sure to look in the on-demand section. So on to our 4 $25 Amazon gift cards. Our first winner is Maria C. Our second winner is Derek N. Our third winner is Joyce N. And our fourth and final winner is John M. So to our 4 winners, congratulations. Please keep an eye on your inbox to claim that gift card. But if you do not see an email, please check your spam folder. Heider and Daniel, again, thank you so much for coming on the show today. Thank you to Snowflake for sponsoring our program. And of course, before we leave, I'd love to thank our audience. We really appreciate you spending time with us today. We ask for one extra moment of your time to fill out a brief survey that should pop up on your screen, but otherwise, we hope to see everyone at an upcoming Techstrong learning program. Everyone have a great rest of your day.